Julie Lealoha. I'm a biologist with the Big Island Invasive Species Committee. During my youthful years, I was actually not interested in science at all. I was more interested in surfing and camping and fishing and just being outdoors.
As I was growing up, I was one of those kids. After school, you'd find me underneath the bridges and the streams, turning over rocks, looking for living things. In there, I was just fascinated by living things growing up, and I guess I never outgrew that.
My dad used to take us fishing and surfing and snorkeling from when I was 4 years old up until I was in high school. And that, at the same time with watching an awful lot of Jacques Cousteau when I was a kid, got me interested in this stuff.
I was always interested in almost anything outside, so I would collect butterflies and rocks, and of course in Kailua there are not that many different kinds of rocks.
I've always been excited about fishies. Science is really the only way you can play with fishies all the time. So, you know, I've always been fishing, diving, surfing, so I just love the ocean.
And I always knew I liked the marine environment, but I was very intimidated by science because I thought that you had to be really smart and, you know, good grades and everything like that way back in high school, and I didn't have those things.
It never really occurred to me until I was much older that I could actually make a living doing the things that I liked the most. Eventually it was a friend of mine that sort of talked me into getting into the science programs, and eventually I decided to go to college.
Then I went off to New Jersey, went to Princeton for 4 years. Took a year off, went to Japan. Took another year off, worked at the volcano at Kilauea for a year. And then I went to graduate school in Boston at MIT for 5 years.
In school, I enjoyed biology, and when I went to the University of Hawaii, I got a degree in zoology.
I'm really interested in marine biology and I love it and I want to make a difference. And I liked science. I've always liked asking questions and stuff. So I tried calculus and chemistry and physics and all those things. And while I struggled really hard my last 2 years in community college to get all the basic courses done and catch myself up, I enjoyed it. And I did well, and then I was able to transfer to UC Santa Cruz, where they have a Bachelor's of Science in Marine Biology. And I did my last 2 years of undergraduate work at UC Santa Cruz.
So it wasn't until I went to college that I discovered geology, and even though I went to college for a different reason, as soon as I took my first geology course, I was hooked.
I went to school at University Laboratory School, and now I'm a graduate student at University of Hawaii, and I work at Hawaii Institute of Marine Biology. My department is part of CTAR, College of Tropical Agriculture and Human Resources, and I do various things related to aquaculture, fish physiology, endocrinology, and aquaculture.
Aloha kako, o ahia dai ko inoa ano kailua mai au. I am a student here at UH Hilo. I'm studying Hawaiian Studies and Astronomy. I entered college thinking that I was only going to be able to do one, and I chose to pursue science. And as I continued on in school, I realized that there was a part of me that wanted to also include Hawaiian Studies. And so I came to University of Hawaii in Hilo and enrolled in Kahakaʻula Ke'elikolani Kalamai. And I enrolled in Kahakaʻula Ke'elikolani, the Hawaiian language program, and began to pursue both of my interests.
My thing is to try to get more local kids interested in pursuing the marine sciences. So I'm tasked with trying to translate the research that we're doing in the northwestern Hawaiian Islands to the public and to K through 12. So that's my mission here. I went to UH and after I changed my major from business to zoology, I got a bachelor's in zoology, a master's in zoology, and then I went to California to do a PhD at UC Berkeley, and I studied Hawaiian bottomfish in the main Hawaiian Islands and the northwestern Hawaiian Islands.
I was recently hired by Albert Takon, who is now the aquaculture coordinator for University of Hawaii System. And this is his lab here at HIMB. And our focus will be to look at native species only. Ornamental fish like yellow tang, flame angel, these fish there's a high pressure on them from collectors, meaning that people go out and collect them from the environment and they're not able to sustain themselves. Their numbers are decreasing rapidly. This is a reason we want to focus on native fishes. Also, we'll be looking at food fish like moi and kahala, and hopefully doing aquaculture studies with them here.
Hydrology, especially today, is pretty broad. It has to do with anything to do with water, really. I tended to focus on groundwater, which is the water that goes underground, but I also work with everything from how rain forms, how it impacts the trees, how trees take it up, how the ground takes it up, how the rivers take it up, its pathway from the mountains to the ocean in its different forms, whether it's streams or underground.
Probably the most interesting to you guys is that I work on how lava flows and how lava tubes form and how they work. And so I have to watch a lot of lava tubes and lava flows. One of the things I do every week is I go out and I measure how much lava is coming out of the ground. And the way I do that is we find out where the lava tubes are inside the lava flows. And I do this measurement across the top that measures how a radio wave gets sort of screwed up by the conductive lava inside the tube. To measure how much it's screwed up, that tells me how much lava is in the tube. And then sometimes these lava tubes have skylights or pukas on the top of the tube where you can see the flow inside. And I take like a radar gun like policemen use or like they use to time baseballs. And I point the radar gun inside the skylight and it tells me how fast the lava is flowing underneath. So if I know how much lava is in the tube and I know how fast it's moving, I can figure out the output, like in gallons per minute. And the average output of the eruption these days is about, it's actually kind of low, it's maybe 30,000, 40,000 gallons per minute.
At the Coral Reef Ecology Lab, we're interested in the coral reefs. And the coral reefs involve a wide variety of things. And leading scientists now know that there are major impacts that are going to be affecting coral reefs in the future. And these are not only global impacts, but also local impacts as well. So we're trying to address these problems. And two of the main problems with coral reefs globally have to do with global climate change. One has to do with anthropogenic or human-induced atmospheric gases, mainly due to fossil fuel burning that is going into the atmosphere, and it is raising the atmospheric temperatures. It's also raising the ocean temperatures. So global warming is affecting our coral reefs as well as many other things. So we're looking at how corals grow under different temperatures, what species of corals will tolerate which temperatures best.
Currently I'm working on several different projects. Science-wise, I'm working on projects involving the largest scales in the universe. I'm very much interested in how galaxies are placed throughout the universe, and I've been working for many years on that particular project. And in order to do that, I have to look very far away into very far recesses of the universe. And so I've also been very much interested in active galactic nuclei like quasars and very bright things, very active galactic centers. And I use them also as signposts in the universe to measure the rest of my project.